I've exaggerated in my drawing over here. This angle, or the angle that the bracket moves, is extremely small. It's very minute, and that's why I can assume that these lines are actually straight because the angle is so small. So now that I found out what delta C is, I'm gonna use the ratio using similar triangles between delta C and delta A prime. And so the ratio between those two, once again, is gonna be 0.4. So the distance between point C and point B is given by 0.4 meters. So it's going to be this side of the triangle, 0.4 multiplied by the delta A prime. And that will be equivalent to the longer side, which is from A prime to B, which is 0.5 meters. Multiplied by delta C, or that side of the triangle. Now I've already figured out what delta C is, so I'm just gonna go ahead and I'm gonna plug in delta C into here, and what I'm gonna get is gonna be delta A prime is equal to 0.5 meters divided by 0.4 meters multiplied by delta C, which is 6.97 times 10 to the power of -4 meters. Okay, so what I'm gonna get over here is delta A prime. It will equal 8.713 times 10 to the power of -4 meters. -4 meters. And that answers the second part of the question. So actually we can even make this better and say that delta A is equal to delta A prime is equal to 8.713 times 10 to the power of -4 meters. So once again, just to go over the question, all we did over here is create another identical point to point A, because like I said, the distance between point A and point B is 0.5. So I just created a point that is exactly the same distance from point B as point A is over here. So I know that the displacement of my new point, which is A prime, it will be exactly the same as point A. So if you were to actually calculate directly what the displacement of point A, or maybe you were to run an experiment, you would find out that point A indeed would move by 8.713 times 10 to the power of -4 meters. So that's another 4 marks. Part C says, find the shear stress in the pin at point B, given that the pin has a diameter of 60 millimeters and is located in double shear. Now, what does double shear mean? So the first thing they actually want us to find out is the shear stress. So for that we're gonna need to use the formula tau is equal to V over A, in which V is the shear stress and A is the cross-sectional area of the pin. So here's the little diagram that I want to show you to explain exactly what double shear means. So let's imagine over here that this is a cross-section of the hinge that you see at point B right here. So you can see that there's a little triangular plate and there's another one exactly like it on the other side, and pin B goes through those two plates and also goes through that bracket. So this diagram right here represents what you would see as a front view. So if you were looking on directly in that direction, so let's say you were standing right in front of it and you were looking on straight ahead, that's exactly what you would see. You would be able to see the bolt going through, and you would be able to see the left hand plate and the right hand plate, and that plate in the middle would be the bracket. And as you can see over here, sorry, the force caused by the bracket, or we're gonna call it FB, is causing a double shear. So there is shear force in that direction, there's force in that direction, and there's force in that direction as well. And that's gonna cause shear in this area over here as well as in this area over here. So we don't only have one kind or one area where there's shear, there are two areas, and hence the name double shear. So what they want to know is what the shear stress at a single area is going to be. And so in order for us to find out what it is, we actually have to figure out what FB is. So if we need to find FB, we know that FB is made up of actually the following. So FB is the magnitude of FB is made up of the magnitude or the addition of the two reaction forces, Bx and By. Right, so if we go back over here, we're gonna need to add Bx and By together in order for us to get the resultant force Fb, which is the force created by the bracket on the pin. So this is where actually the Fx and Fy formulas, or the sum of forces in the x and y direction, come in handy, because we do actually need to figure out what Bx and By is. So we can go ahead and figure out what By is, because there's only one known in this equation. And let me write it in a different color. So once you solve for By, you should get By to equal minus 187938.52 newtons. So that is the y component of the force at pin B, and we're gonna use the sum of the forces in x direction. Now we've already figured out FD and FC in part A, so we're gonna go ahead and plug those in, and all we're gonna have left is Bx. So we're gonna solve for Bx, and then we should get minus 16753.2.05 newtons. So I'm just gonna take Bx, By, square them and add them. So what I'm gonna have is gonna be as follows. So it's gonna be Fb, or the magnitude of the force Fb is gonna be 18793.8.52 squared plus 167,532.05 newtons, and then we take that and square it, and then we take the square root of all of this. And so Fb, we should get the magnitude of the force Fb will be 251769.49 newtons. Now that we figured out what Fb is, all we have to do is just divide it by 2, because we actually want to find out what the shear force for one side is. So we just need half of the force Fb. So once again, using this equation right here, the shear stress equation, we're going to say tau is equal to, so it's going to be Fb divided by 2 divided by the cross-sectional area. So once you take Fb divided by 2, you should get 125,884.75 newtons. And since they told us in the question before what the diameter of the pin is, I believe they said it was 60 millimeters. Yeah, it's right here. They said it was 60 millimeters, so we're going to use the diameter to figure out the cross-sectional area of our pin over here. So what I got was 5.65 times 10 to the power of negative 3 meters squared. And once you divide those two together, you should get 22.28 gigapascals. Okay, so that is the shear stress that is caused by the bracket on the pin that they have provided us with. And that completes the third part of the question. I think overall this is a pretty straightforward question. If you do it right at the beginning, it's a 3-hour examination. That's your first 20 marks right there. Now you're just down to 4 more questions before you can complete the examination. If you have any questions, please comment below and I will answer them as soon as I can. Thank you for watching.